Okay. And yeah, so we took this statement in English, tried to rephrase it more formally, um, negated it twice. That doesn't change its truth value. The point of this is really to try to flip for alls to a there exists, and we sort of worked through this last time. I guess I'll go through it again quickly. So we would like in this query to return all restaurants where a person goes to the restaurant and the restaurant in which this person goes has a food that they like to eat, and the person also, excuse me, the restaurant also serves the food. So the outer knot is going to be a set difference, and the inner knot is flipping the for all. And that logically goes to, instead of for all restaurants this person goes, there exists a food that they like to eat and the restaurant serves it, to there exists a restaurant that this person goes such that all the foods that are served, the person either does not like to eat it or the restaurant doesn't serve it. And this statement has another for all, which we flip again, and using this sort of same trick where we have the outer knot being a set difference, the inner knot flipping the quantifier, changing that for all foods, either the person doesn't like to eat it or the restaurant doesn't serve it, to there exists a food that the person likes to eat and the restaurant serves it. So the overall type of thing that we're working through here is two set differences. These are both due to these outer knots, and separating from that a there exists statement, which is where we end up with this flipping this innermost for all to a there exists. Now, I left off with the actual query itself, which I'll put here. And I, yeah, sort of gave it to people to mull over. What the whole reason why I was going through all of that stuff above was because, oh, let's see if I can move this easily. Yeah. Sorry, I want to move this stuff out of the way. Ugh. Sorry, I'm trying to make this nice. Yeah. I did not just want to go from. Ugh, man, still not good. I need a little bit more room. I didn't just want to go from the statement to the query, and I can explain the query fine, and you can see that the query matches the sort of truth of uh, the English, but the real question is how do you go from one to the other? And so that's what I was trying to do, is to come up with a way for people to go from one to the other. All right. All right. Not perfect, but good enough. All right. So here is the query. Find the names of all the people who frequent only restaurants serving at least one food they eat. And the only here is the real trick of what makes this query difficult. So for all restaurants that this person goes, the restaurant serves something that they like to eat. Move this a bit more. Okay, so what I want to try to do is to break this statement up into these things that we worked through the last class. So, this part of the statement, this is a natural join. So, it's a natural join spelled out, and I guess one thing I want to touch on real quick is why I'm not going through natural joins and why you can write it with a sort of bow tie, but I'm trying to avoid it, is because a natural join is something that you can reproduce using more basic operations, namely a select and a cross product. And that in the real world, after this class, you can use joins. When I'm teaching SQL, I will also be avoiding joins, even though they're a thing and you'll see them, and you should use them because it's easier to do so. Um, Actually understanding how they work is why in this class I'm trying to enforce not using them. There's examples of students who will say that something can work with a join, but without it, they don't know how to do it or they don't know what's happening. And so I'm just avoiding joins. That's really just to try to enforce understanding what's actually happening. Um, So, okay, this is basically a join where we take there's two things here. There's the eats relation and the serves relation, and we're interested in the foods that people eat as well as the restaurants that serve those foods. And well, I guess instead of sort of just feeding it to you, is there with what I've highlighted here? How would you phrase this in English? What is this portion doing? This portion of the query.
Is that showing the foods that people eat and the restaurants that serve them?
Uh, can you be more specific?
Can you hear me?
Yeah.
Sorry, my AirPods has died, so I don't really know what you want me to get at, but um that would just um oh well, it would pick out the name and the restaurant um out of a joined table that would produce the name of each person, the food that they eat, and the respective restaurants that serve those foods.
Yeah, great.
Okay.
Excellent. Yeah. So this is a restaurant that serves at least one food that the person likes to eat. Yeah. Thank you very much, Brian. Um, so this is, um, I guess, name restaurant. So this is the pie here. That it's a name restaurant pair. Uh, such that, which I'm writing just st, um, the restaurant serves at least one food um, the person likes to eat. Okay. And so, how about this part? Now we're expanding this. So it's this the a set difference. How would you phrase what the set difference is doing? That's an open question. Anybody can take it. We are taking the restaurants that people go to and only want to keep those same restaurants where the food they eat is served at the restaurant they go. Yeah, sorry, Tashar. I can't tell if you're responding to the green or the red. If the red part not quite right. Um, it removes people from the set that are matched with a restaurant they actually frequent. No, not quite right. Toyin says deletes all the combinations that are the same and then just gives you the remaining foods that are left. Also, not quite right. So, here is people who uh, go to some restaurant such that there's some food that they like to eat that's served at the restaurant. And um, there's the restaurants that people frequent, and you're taking away from the restaurants that people frequent those restaurants that serve something that they like to eat. So, who remains from this group? To me, this is a very, very tricky kind of query. And again, this is why I spent a whole class trying to go over this hopefully systematic way to derive this. But yeah, so there's restaurants that people frequent, restaurants that people go to. And from that set, you're taking away the people who go to restaurants that serve something they like. So what remains? People that frequent restaurants that do not serve at least one food they like. That's closer. That's much better. Yeah. It's closer. This, I'll write it. This is people who frequent only restaurants that serve nothing they like. Yeah, good job, Jamie. You were pretty close. Um, so it's an odd group of people who only go to restaurants that serve things they don't like. But if there's people who only go to restaurants that serve things they don't like, and if you take away from that, or if you remove those people from the group of people who just go to restaurants, then what remains are people who go to restaurants that serve at least something that they like. Okay, so again, I can explain each part of this and why the logic works. I'll repeat it. This is you take all people. This is the person table, and from these people, you remove people who only frequent the restaurants that serve things that they don't like. So what remains are people who frequent restaurants that serve something that they do like. Okay? Um, and in order to get the list of people who only frequent things that serve stuff that they don't like, um, you take the list of all the places that people do frequent and remove the people that go to a place that serves at least one thing that they like. So that's it. Ah, yeah. Complicated. Again, I would not expect anybody to be able to go from this type of statement to derive this type of query. That seems very, very difficult to me. I'm not sure how other people do it, the way that I was able to come up with was this logic maze that I spent the last class on. Are there questions about this? Um, there's I'll move on and I'll finish the class with another very, very related example. Um, but insofar as how this one example plays out, are there any questions? Thank you, Danielle. I appreciate some type of answer as opposed to just a deafening silence. Thank you. Okay, let's move on. Great. So, whatever. The tables and their schemas are really all that matter here, but there's some play data if it helps. Now, these are people who frequent all of the restaurants that serve at least something they eat. So, I don't know, maybe these are food critics and they eat stuff and they like it and they're going to visit every single restaurant that serves something that they eat. So that way they can write a big blog post about their opinions on how that restaurant's food is. We won't be friends with these people, but yeah. Um, I will give you, let's say 5 minutes to work through this. I will give you the hint that this is very close to the last example we worked through. I might attempt to give a different type of explanation about how it works, just because, but in the meantime, I'll give you some time to try to work through it. Yeah. Sorry, I'm trying not to block the table here. I guess that's hopefully it's. Oof. Sorry, I'm not trying to do it. Yeah, hopefully that's okay. Alexa, lamp on. Okay. Any tries for an answer? Not yet, but stuck. Okay. Pie name person, pie name, restaurant. The rest is the same. Um. Okay. First, Alejandro, do you have uh a microphone? Can you maybe say why you're confused or where you're confused? Where you?
Yeah, I'm just confused on like just where to start. Um,
Yeah.
so no, before you did that whole line of the query,
Mm-hmm.
but like I'm trying to like work inside out, but like it's still kind of confusing to me. So it says find the names of all people who frequent all the restaurants serving at least one food they eat.
Mm-hmm.
So the first thing you would do is just I guess what would be the first thing you need to do? I know because we have to do some like subtractions eventually, but like I'm just trying to see how can I approach this and in general how can I approach a query like this.
Yeah.
So I guess like the first thing we have to do
Mhm.
um so I guess find the restaurant that people frequent um that serves at least one food that they eat. Is that the first thing we have to do?
Yeah. So this is, I mean, this is these types of queries are the most difficult, I think.
Yeah, I'm
They're
just confused
again.
at least one part.
So at least one. That means that there exists. That's what that corresponds to. So there exists a food that they like to eat, and the restaurant also serves it. Okay. Let's see. So we don't have so much time. I can't work through the whole logic the same way that I did with the previous example, but I'll try to give first. I'll write the query. So um, this would take the names of people minus people who let's see. Just a minute. Okay. So, this part, the sigma and this cross product with a row is just doing an inner join. So this returns this part. Highlight it. This part returns the names of people who eat at a restaurant that serves something they like. And from this, you're removing the restaurants that people frequent. And from that, you take away the people who, oh, sorry, this is there you go. This part, you're removing the people who don't go to restaurants that, oh boy, man, yeah, this is hard to phrase. How do you do in restaurants when eats doesn't have restaurant in it? Hold on just a minute. Sorry, you're right. This should be food. Thank you, Toyin. Thank you. Okay, so I'm going to try to give another explanation of how this works. So, if you have a table A, or a table T1, you have two tables, T1 and T2. And T1 has some attribute A and some attribute B. And T2 has some attribute B. Then taking T1 divided by T2, what this means is that for every entry of in T2, there exists a corresponding entry in T1. So what this should return are returns all entries A such that T1 has an A, B for all B's in T2. So this is really what's happening in this type of query. You have two tables, and one table has more than one entry, and these columns, you know, A here could be multiple columns, B could also be multiple columns, but the thing that's happening is that you want to return from table T1 all of the rows where there is an entry that exists for an entry in T2. So if T2 has, let's see, let me do this. This is entries for T1. And let's do this, P2. Then we want a table AB. And this will just have values of A. So what this is saying is here's a table T1 and a separate table T2. And what we want to return, this A/B, are those entries where what appears in table 2 has a corresponding entry in table 1. So what should this table look like? What entries should this have? One, two, three, and 4. Correct. Yes. So P2 appears for entry 1. P2 also appears here in entry 2. P2 appears for entry 3. And P2 also appears in entry 4. So this is 1, 2, 3, and 4. Excellent. Okay. So this is sort of the type of query that we're trying to realize here. This would be the restaurants that people frequent, and this would be the people and the restaurants that they go to and the foods that they eat. There's, let's see. So T1 is a relation with A and B. Division finds all values of A in T1 that are connected with values B in T2. So think of this like A, B divided by B equals A. So here, T1 divided by T2 equals pi A T1 minus pi A of T1 cross T2 minus T1. Okay, so this query here is, I hope there's enough room on this screen. There is not. Yeah, this is T1 minus T1 cross T2 minus T1. So this is all possible A, B pairings. This is all real A-B pairings. Okay, so this is what this query is really about. You're first, you come up with all of the possible pairings and you remove from it the ones that actually exist. So what remains after, so you take all of the possible pairings and you remove the real ones. What remains are the pairings that don't exist. And for the pairings that don't exist, you remove from that the pairings that are actually there. So here, you take all of the possible foods that are served that people eat, and you remove from that those restaurants that serve them. Sorry. Oh boy. So this is just like the previous query, except for the frequents and this part, they're reversed, basically. Yeah, I don't know. Maybe this is a simpler way to try to understand this. Let me try to write this a bit more explicitly. And I'm sorry, the class is over. I'll take one more minute. So um, my pen's not working. Come on. Right. Sorry, I'll have to type. Okay. Sorry, my pen just died on me. So for all the values of A here that are connected to values B, let me try to move this up. Do it this way. Okay, so for every value of A that's connected to a value of B, you do this set difference. And so for all of the possible pairings, you remove from them the ones that actually exist. And so the difference, removing those from the original set, are those that are not connected to every single value. I can work through an example of this. I might do this next class, but in any case, I don't want to take more of your time. I know we're past class. So I hope this has been clear, and yeah, we'll pick this up next class. Maybe I'll work through an example. Thank you, everybody.